When you hear quantum, you probably picture futuristic computers solving impossible problems, but the real quantum revolution might already be happening, just not where you expect. While quantum computers grab headlines, another branch of quantum technology is quietly advancing. Quantum sensors. These devices use the strange rules of quantum mechanics not to compute, but to measure the world with unprecedented precision. Quantum sensors are the unsung heroes of the quantum age, bringing immediate, tangible advances to our lives. Instead of waiting for one giant leap, this revolution is arriving through countless small, powerful steps. These sensors are set to transform navigation, medicine, and our understanding of the planet, long before quantum computers become mainstream. So let's step out of the spotlight on quantum computing and explore the hidden story of quantum sensors. This is the story of the quiet pioneers shaping our future, one measurement at a time. Every day we rely on measurement, checking the weather, using GPS, or even visiting the doctor. Measurement is the silent engine of modern civilization, translating the physical world into digital information. Our progress depends on how well we can sense and measure, from building safer bridges to exploring distant galaxies. But classical sensors, like rulers or microphones, have limits. They're easily overwhelmed by noise and imperfections. Imagine trying to hear a pin drop at a rock concert. No matter how good your microphone, the noise drowns out the signal. What if we could build sensors that operate on entirely new principles, so sensitive they can pick out the faintest signals, even in chaos? Quantum sensing promises just that, a fundamental shift in how we perceive reality. It's not just about making better rulers, it's about inventing new ways to see the world. This is where the quantum story truly begins. So, what sets a quantum sensor apart? It's all about harnessing the weirdness of the quantum world. Classical sensors measure averages from trillions of atoms. Quantum sensors use individual atoms, electrons, or photons, leveraging their unique properties. Superposition lets an atom exist in multiple states at once, like a spinning coin that's both heads and tails. Quantum sensors prepare atoms in this delicate state, so even the tiniest disturbance, like a faint magnetic field, can be detected. Entanglement is another quantum trick. Two particles become linked, so measuring one instantly affects the other, no matter the distance. Entangled sensors can cancel out noise, isolating the signal you want. This isn't just more sensitivity, it's a fundamentally new way to interact with reality. Classical sensors are tossed by every wave. Quantum sensors dive deep, reaching the calm depths where true signals reside. By tapping into the quantum realm, these sensors achieve almost supernatural perception. They're not just better, they're different. That's the quantum advantage. Quantum sensors aren't a single invention. They're a toolbox of extraordinary instruments. Atomic clocks use the vibrations of atoms to keep time with mind-blowing accuracy. So precise they wouldn't lose a second in billions of years. These clocks improve GPS and can even sense gravity, mapping the Earth's gravitational field down to centimeters. Quantum magnetometers detect minuscule changes in magnetic fields, thousands of times more sensitive than classical devices. In medicine, they could lead to wearable brain scanners, mapping neural activity in real time. Quantum gravimeters measure tiny variations in gravity, revealing underground water, minerals, or even monitoring the stability of the ground beneath cities. These tools give us new senses, letting us perceive the hidden workings of our world. From timekeeping to brainwaves to the pull of gravity, quantum sensors are expanding our reach. They're not science fiction. They're being built and used today. The quantum toolbox is already transforming how we see reality, and it's just getting started. GPS guides our world, but it's fragile. Lose the satellite signal, and you're lost. Quantum sensors offer a revolutionary solution: navigation that doesn't rely on external signals. Quantum accelerometers and gyroscopes use supercooled atoms to measure movement with astonishing precision, thousands of times better than today's devices. These quantum compasses don't drift, keeping perfect track of position for days or weeks without GPS. Submarines could navigate the deepest oceans silently. Aircraft could fly safely through GPS-denied zones. Autonomous vehicles and first responders could always know their location, even indoors or underground. For defense and infrastructure, it's a game changer. An unjammable, resilient navigation system. This isn't just an upgrade to GPS, it's a fundamental backup for our way of life. Powered by quantum laws, we'll always know where we are. The quantum compass is navigation, reimagined. Our planet is alive, but much of its activity is hidden until disaster strikes. Quantum gravimeters and gradiometers let us listen to the Earth, measuring tiny gravitational changes to reveal what's beneath our feet. Geologists can map underground water, minerals, or monitor ground stability, all from the surface or the air. These sensors could predict volcanic eruptions or earthquakes by detecting subtle shifts long before catastrophe. In medicine, quantum magnetometers can create wearable brain and heart scanners, detecting faint signals classical devices miss. They could spot disease markers in a single drop of blood, enabling earlier, more accurate diagnoses. Quantum sensors are opening new windows into the Earth and into ourselves. We're learning to see the previously unseen, making our world safer and healthier. The quantum revolution is about understanding, not just computing, and it's already changing lives. Building a universal quantum computer is a monumental challenge. Fragile qubits, extreme isolation, and daunting engineering. Quantum computers are still confined to labs, far from everyday use. Quantum sensors, however, thrive on sensitivity. They're designed to interact with the world, not hide from it. A single atom, or a small group, can do the job, making sensors easier to build and deploy. Each sensor is tailored for a specific task, measuring gravity, time, or magnetism, so they're simpler and more robust. That's why quantum sensors are already leaving the lab and entering the real world. They're winning the quantum race because their finish line is closer, and their impact is immediate. The first wave of quantum technology isn't about computation, it's about perception. The quantum revolution isn't a single event, it's a journey, and quantum sensors are the first real steps. They're solving real-world problems now, not in some distant future. Focusing only on quantum computers misses the profound advances happening today. Quantum sensors are the foundation for all future quantum technology. The skills and techniques developed for sensors, like laser cooling and atom trapping, are paving the way for better quantum computers. Sensors are the training ground, the laboratory, and the first commercial products of the quantum age. When we talk about the quantum future, we should celebrate sensing, timing, and communication, not just computing. This broader perspective gives us a more hopeful, accurate view of progress. The quantum age isn't coming, it's here, and sensors are writing its opening chapter. Let's recognize the revolution already underway. The universe's secrets are written in gravity, magnetism, and the rhythm of atoms. For centuries, we've tried to read this hidden language. Now, with quantum sensors, we finally can. While the world waits for quantum computers, a quieter revolution is unfolding. Quantum sensors are making navigation more resilient, healthcare more predictive, and our understanding of the planet deeper. Progress doesn't always arrive with a bang. Sometimes, it's the whisper of a single atom. These devices are already reshaping our world, connecting quantum mechanics to everyday needs. So next time you hear quantum, think beyond computers. Think of the breakthroughs happening now. The quantum revolution is a silent, steady transformation. And it's already here.